G'day guys, Socket here. Today we're going to continue on with our how to design and plan a car audio system tutorial series, and we're up to episode 6, which is car types and design choices. Now the type of car that you've got, whether it's a petrol car or an electric vehicle, whether it's a sedan or an SUV or a hatchback, will all play a major role in how your sound system gets installed in your car, and the choice of your speakers. Simple things like how big your A pillars are on your windscreen. What size speakers can you fit there, or how big are the speakers that you could fit, for example, in your door cards? Where can you place your subwoofer? Stuff like this is all going to be dictated by the size, shape and dimensions of your car. And so we're going to talk about that stuff today, as well as how the dimensions of your car affect sound and acoustics, your plans to resell the vehicle, the drive type of car you've got, a whole bunch of stuff. So we're going to go and work through all of this today and look at how your vehicle affects the design choices for your car audio system. Okay, well, before we get into today's episode, I thought we'd do a little recap. And of course, this whole series is on design and planning your car audio system. And we are, at the moment, working on the design part of that journey. And if you remember an episode or two ago, we came up with this little diagram to put stuff into different buckets. So we had the design side. So, we're working out what we want to build, and then once we know what we want to build, how we're going to use our tools and our knowledge to put the whole project together. And that's the planning side, which we'll come to in some future episodes down the track. And of course then there are some things that kind of sit in the middle. So far we've really been focused on the design, and the thing that drives your design are your preferences. And of course in episodes 4 and 5 we looked at those preferences, including the style of music you like to listen to, the sound quality that you're aiming to achieve with your system, how loud you want your system to play, some of the trade-offs like how whether you want to keep the car looking factory or whether you're happy to do customization, how important is space versus the performance of the system to you. So we looked at this question of how important is storage space and cabin space versus how much spare space are you willing to give up for your system, because the answer to that had implications in terms of storage space that you had available in the car, and where you could place your mid basses, and whether you use slimline subs or not, things like that. So this was the space performance trade-off. So back to our diagram, we've largely worked our way through all of these preferences and talked about how they will influence your car audio design. And now we're going to look at these things that both influence the design and how you're going to actually execute the project, right? And so today's topic is on the car. So how your car, with its unique dimensions and features and stuff, how your car is going to influence the design of your car audio system. So cars come in all shapes and sizes. There are small compact hatchbacks and four-wheel drive SUVs, and 8-seat people movers, 2-seat sporty coupes, and the list goes on and on. And each of these cars has a different set of dimensions and different sets of materials and things that are used in the build, and of course different features, and all of these things have an impact on your car audio design in terms of what you can and can't do. So some of the topics that we're going to cover today include the size and shape of the vehicle, the length and width and the cabin volume. So maybe you've got a small hatchback, or maybe you've got a big SUV, and of course these two different cars have different cabin volumes, and these things will affect the acoustics of the cabin, things like standing waves and cabin gain, and other things. So we're going to take a look at those types of acoustical issues, and how that might affect things like your speaker choice or speaker placement. We're also going to take a look at the design and features of your car. So the size of the pillars, how much space you might have behind your door cards, how big is your trunk, whether your trunk is enclosed or part of the cabin like it is in a hatchback, and how the actual features and the design of your car can influence the design of your car audio system. Then we're going to talk about something that we've touched on in a previous episode, the value of your car, whether it's old, new, expensive, not so expensive, how that might influence the design of your system, and things like ownership. Are you leasing the car? Does it belong to your wife, for example? Whether you're going to keep the car or resell it. How those things might influence your choice when it comes to car audio design. And of course, we're going to look at the drive types. So we're going to look at petrol, electric vehicles and hybrids, and what makes these vehicles different, and the things you need to be aware of when you're designing a car audio system, for example, if you have a hybrid car. So we've got a fair bit of ground to cover today. So let's dive on in and get started with size and shape. Maybe you've got a ute. Well, in Australia they're called a ute, but I think in the US and other places they're called pickups. So maybe you've got a pickup, it might be a single cabin or a twin cabin, or maybe you've got a small hatchback or a work van or a station wagon or a four-door sedan or a two-door sporty coupe, or maybe you've got an SUV or even a convertible, or maybe you've got an F1 race car. Oh, well, okay, so maybe most people don't have an F1 race car, but I guess the point is that no matter what type of car you've got, they all come in different shapes and sizes. And specifically, there are 3 different characteristics of your car that will affect the way your car audio system will sound. And those 3 things are the cabin dimensions, or in other words, the size of your cabin, the driver's seating position, so how far back from the windshield and the side windows you're sitting, and the third one is what I call trunk versus hatch. In other words, if you have a trunk, is it enclosed, like in a sedan, or is it not? Is it part of the open cabin space? So these are the 3 unique things to do with your car that will have an impact on the way that your system will sound. So let's start by having a look at the first one, which is the cabin dimensions. And so I'm going to use just an example here. So I'm going to take a single cabin pickup, a large SUV and a small hatchback, right? Just to explain cabin dimensions and how they kind of differ. But if you think about it, each of these cars has a different cabin length. So if you think about the SUV, the length of the cabin, not from the front bumper to the rear bumper, but the cabin itself, right? The internal space of the car is going to run from the rear window or tailgate all the way through to the windshield, right? And that's quite a distance, 2.5, 3 meters, 3.5 meters, or whatever it is for an SUV. And you compare that to a small compact hatchback, which once again, from the rear window to the front windscreen. But it's a much smaller car, so that distance is much smaller, right? And if you think about a single cabin pickup, the cabin length finishes just behind the front row of seats. From the rear window to the front windshield is a very small distance, maybe a meter and a half, something like that. But you can see that each car has a different cabin length, and of course, depending on the size of the car, they also have a different cabin width and a cabin height from the headliner to the floor. Once again, these will all differ, smaller in the small cars and larger in the larger cars. But when you sort of add them all up, each car will have its unique combination of length, width and height to give it a specific volume, right? And of course, throw into that where you put where your driving position is. In the pickup, the driver is physically closer to the windscreen than maybe in the SUV, right? how close you are to the windscreen and the side windows, and that type of stuff will affect reflections. How you hear reflections and things at the driver's listening position. Where you locate your speakers relative to the driving position, how far those speakers are away, how they're aimed, where you've actually located them, whether they're on the pillars or on the dash or in the kicks. All of these things will affect the reflections, the cancellation, comb filtering, standing waves, cabin gain, all of these types of things, and what we call the cabin response of your particular car. And it's this cabin response and this unique combination of dimensions, seating position, distance from speakers, speaker aiming location, distances from side windows and windshields, all of these things that are unique to your car and your seating position and how you've set your system up will give a particular cabin response. And it's the reason why one brand of speakers might sound great in one car but might sound totally different in a different car, right? And so, yeah, when we talk about cabin dimensions, these things have a huge impact on how your system will sound. And one of those things is what we call stage width. So stage width is, as the name suggests, how wide the sound stage is on your dashboard. And it's largely dictated by how far apart you can place your left and right speakers. It's not the only thing. Speaker aiming and a whole bunch of other stuff comes into play as well. But in general, the further you can place your left and right speakers apart, the wider your stage width will be. And so, of course, in larger cars with a larger dashboard, you can physically place the left and right speakers further apart than you can in a smaller car, which, helps to produce a wider stage width. And what this does is, let's say that you have, a singer in the middle of the dash, and then you have, your drums playing on the right and a guitar playing on the left. Well, in a larger car, those instruments will be more separated because there's physically more distance between the center point and the left and right, compared to a smaller car. The trade-off is that there are longer path lengths for sound to travel to the driver or the listening position than in a smaller car. So it means that doing time alignment is a little more difficult because you've got longer path lengths to deal with, right? But as a rule of thumb, as I said, it's not entirely to do with left and right placement, because speaker aiming and a bunch of other things come into play that can contribute to stage width. But in general, the wider your car is, the greater the stage width of your sound system. Okay, let's talk about seating position. Now, all cars have different seating positions, and I'm not talking about, moving the seat forward or back or up or down. That's about you setting up the seat so you can drive comfortably, right? What I'm talking about is the driver's seat position compared to how far away they are from the different speakers and on what angle it then puts the driver's listening position, and how far you are away from these highly reflective surfaces, these glass surfaces like the windscreen and the side windows, right? So if you're in a car like a work truck or a people mover or something like that, where you sit very close to these reflective surfaces, then it's going to sound very different to if you're sitting in a coupe or a family sedan or something where you're much further away from the windscreen and the side windows and stuff like that. But let me try to explain. So here I've got two diagrams. I'm going to call this the family sedan and the work van, right? The difference is this one is where you're sitting much closer to the windscreen and side windows than this one over here, right? So obviously, if you're sitting in the car like this, your angles and of the direct sound from the speakers is going to be different, right? just because of the geometry of where you're sitting relative to the various speakers, right? And of course, the reflected sound is also going to be different because of the geometry of where you're sitting compared to the speakers and the angles. So what does that all mean? Well, it just means that it's going to sound different from those two listening positions because you're on different distances from each of the speakers, on different angles to each of the speakers, and all of that type of stuff. The other thing that sitting position influences is, as I said, how far you are away from the reflective surfaces, and it sets up one thing that we call boundary gain. So the closer that you are to the windscreen and the side window, the greater the boundary gain. And boundary gain is, well, let me explain it like this. Let's say you're sitting in the corner of a room, right? So you're in the corner of the room facing out of the corner, and you're looking at a subwoofer right across the other side of the room, and the subwoofer is playing bass notes towards you. Because you're in the corner of the room, those bass notes are going to hit the wall and they've got nowhere really to go. And you're going to hear them, and it's going to be pretty loud, right, because of boundary gain. So boundary gain is basically when sound bounces off a boundary, like a windshield or a side window or reflective surface. It will bounce and it will the energy will start to dissipate. Right, and this tends to be more your mid bass and subs, those low notes, long wavelength notes, as opposed to your mids and tweeters that play high energy notes. I'm talking about those low notes. They'll bounce off the surface and they will lose energy the further that they travel. So the closer you are to those reflective surfaces, the louder the bass will sound because it hasn't had a chance for that energy to dissipate, right? And you get this bass loading caught because of boundary gain, right? So if I'm sitting in the family sedan, right, I'm further away from those windows, so I'm not going to get as much bass as I would in the van example, right? And this is why in very short cabins like a single seat van, or a single cabin van or a single cabin ute, you can get super heavily loaded bass because you're very small space and very close to all those reflective surfaces, right? The flip side of boundary gain is that the cancellations and peaks that you get in the higher frequency notes are usually much more pronounced. So you have much more problems with peaks and cancellations, because of your in amongst all the reflections, right? As opposed to in the sedan where, those things have had a chance to kind of dissipate before they reach your ears. So, that's seating position and I guess the acoustics of what's happening in your cabin. Well, that's great, Socket, but what does it have to do with car audio design? Well, you can't do much about your seating position or the windscreen or stuff like that. Yes, you can move your seat back and forward, but it needs to be in a position where you can, operate the car and reach the pedals and things like that. So you're kind of stuck with the geometry of the physical car itself. But what you can do is you can change the speaker aiming, you can change the position of your subwoofer, and if you've got a DSP, you can change things like the timing and the delays and the levels and the EQ to shape the speaker responses that you want. So let's go take a look at each of these, and I'm going to talk about speaker aiming first. Now, I've covered this in a tutorial called speaker aiming earlier in the year. So if you haven't watched that, go and check that out. But let me just talk about speaker aiming of tweeters and mids. And the reason I'm going to talk about tweeters and mids is because low frequency drivers like mid bass and subs are largely omnidirectional below a certain frequency, and that means that you can, doesn't matter which way you really face them, they will sound the same roughly. But for mids and tweeters, that beaming, where they go from being omnidirectional to beaming, occurs in the frequencies that we typically operate these speakers. So we tend to find them acting more like flashlights, right? The sound comes out like a beam. And so speaker aiming is really important when it comes to mid-range and tweeters. So let's say that you have your tweeters in the sails or up on the pillars, and your mid-range, for example, up on the pillars. Where should you aim them to get the best sound quality? And it depends on whether you're trying to do a one-seat car audio tune, so it sounds great for the driver, or whether you're doing a two-seat car audio tune, where you want the sound to be good for both driver and passenger. Now, if you're doing a one-seat tune, then you basically want to aim the tweeters and the mid-range at the driver's listening position. Well, not directly at the driver's nose, because you have a glass surface here. And so you've got to be careful with the angle between the tweeter and the glass surface, because you can, have interference from this glass surface and reflections. So you kind of want to aim the passenger tweeter directly at the driver's ear, and you want the driver's side tweeter and mid-range to be kind of aiming at the driver's inside shoulder, the shoulder that is closest to the console, right? Just to avoid the reflections from this glass side area here, right? But for all intensive purposes, you're going to have the tweeters and the mid-range on axis at the driver. Now, as I said, if you're going to do a two-seat tune, it's slightly different, and I'm going to look at two different examples here. One is, so if you take this orange, the solid orange line, this is a two-seat tune, and I would aim the tweeters and the mids at the gap between the two seats. And what that means is, for the driver, the beam is going to be 30 degrees off axis or something, and the same for the passenger, right? So they're pretty much on axis for both driver and passenger, right? But that's just how I would do a two-seat tune. Now, there's very common for people to aim the tweeters to the opposite B pillars, so this sort of yellow dotted line. So the driver's side aimed at the passenger B pillar, and the passenger one aimed at the driver's B pillar, right? And the difference is, for the driver, this one's now on axis, or more on axis, and this one's now off 60 degrees, right? And the same for the passenger, right? This one's more on axis and this one's less on axis. So it's you can do it either way. As I said, it's a bit of six of one, half dozen the other, because for me, this is more of a compromise in terms of the on axis for both passenger and driver, and this one just moves the focal point kind of forward. So you can kind of do either, but that's how those two kind of stack up. So that is talking about tweeters and mids up on the sails and pillars. Now, what about if I have my mid-range up on the dashboard? Like, how close to the window or the glass should my speakers be? Should they be angled towards the windscreen? Should they be angled away? What should I do to get the the best result? Well, glad you asked. In terms of how close should your speaker be to the windscreen, well, if you draw a line through the middle of the speaker, so this is the speaker here in blue, here is the windscreen doing this. So let's say I'm using a 3-inch mid-range, then I should be, from the middle of the speaker to the glass, should be 3 inches, right? That's the minimum distance that you kind of want to be. You can be back a little bit, but yeah, rule of thumb is basically one cone size away from the glass to the center of the speaker. So if you're using a 4-inch mid, then the distance would be 4 inches, just like in the diagram. Okay, so that's great. What about the angle? Well, the ideal angle is if you look at your windscreen versus the the mounting plate of the speaker, which should be flat on the dash. The ideal angle is 55 degrees. And what that means is the the sound will be beaming out of the speaker, and it should be hitting the windscreen at about a 35-degree angle. Now, where did I get 35 degrees from? Well, when you look at a triangle and you do your basic maths, all three angles must equal 180 degrees. I've got 55, 35. This is a 90-degree angle, so this one's 35 degrees, right? This is the angle of the sound wave hitting the windscreen, right? Now, why is that important? Well, because what we're doing when we are firing a sound wave into the windscreen like this, where we have our mid-range up on the dash, the danger is we end up what we call comb filtering. Now, comb filtering is when we have a direct sound wave and a reflected sound wave interacting with each other, and what happens is we end up with cancellations at very regular frequencies that look like the teeth in a comb on the RTA plot. Yeah, we don't want that, because that will sound sound weird. So having this angle of inflection around about 35 degrees doesn't eliminate the comb filtering. What it does is it negates the bad effects of the comb filtering, right? So this is the type of angle that you're aiming for your speaker to be reflecting off the windshield. And that's great if you've got a windscreen that is 55 degrees to the dash or the mounting plate, but what happens if you don't? Well, let's say you have a windscreen that is more than 55 degrees, right? So let's say it's 65 degrees. Well, what you should do in this case is then tilt the speaker towards the windscreen so that this angle is now back to 35 degrees, right? So you might put a 10-degree tilt on it, something like that, right? So that's when the windscreen is more than 55 degrees. If your windscreen is less than 55 degrees, so let's say it's 45 degrees, it's quite shallow, such as a sporty coupe, you tend to have much shallower windscreen angles. Then there's a couple of things you can do. One is to move the speaker back away from the windscreen. What that will do is, this is still a 90-degree 45. This will mean that the angle of inflection with the windscreen is 45 degrees, not 35. But, it doesn't have to be perfectly 35. Within 10 degrees will be okay. So one thing you can do is move the speaker back if you can. Or if you can't do that, then the other thing you can do is tilt the speaker away from the windscreen. And so you end up with, once again, a 35-degree inflection. So that's also a way to sort of fix that up. Now, if you're interested in this sciencey stuff, these measurements and recommendations come from a paper called "The Considerations for Optimal Location and Boundary Effects, blah blah de blah, in an Automotive Interior," right? And it goes through. Basically, I did all the research and summed it up here for you. But if you're interested in that stuff, go check out that paper, and you can read all of the nerdy details. So next, let's talk about subwoofer location and aiming. So we've talked about the high frequency notes, the tweeters, the mids, and the mid-range you can't usually do much about because they're usually in a fixed position. But if you have your sub in an enclosure and it's not sort of permanently mounted in, let's say, a trunk IB baffle or something like that, then this kind of might help. So if you've got the sound bouncing around in the cabin and off the windows and all this type of thing, and you want to do something about the sound of the bass, there's a couple of things that you can kind of do. One of those is to move it to a different location. So, moving it 30 centimeters or a foot in a different direction, or putting it in the corner of the trunk instead of, behind the seats, will sometimes give a different bass response at the listening position. So one thing to try is to move it to different locations and see which sounds best. The second thing to do is to point the sub in a different direction. So you might have your subs down firing or up firing or firing towards the cabin. So changing the direction that the subs are pointing, equivalent to sort of aiming your tweeters, so to speak, may have a different effect at the listening position on the bass. Now, people ask, what's the best way to aim your subwoofers? And that's a difficult question to answer, but generally it's better to aim your subs towards the rear of the car, because the sound will reflect off the back of the cabin, and it will load the interior better, right? So particularly in hatchbacks or SUVs where the cargo space is the same area as the car cabin, it's often the best position offers to fire it back towards the tailgate, right? Because you get boundary loading, right? In a sedan where the trunk is actually enclosed, it varies because you have what they call coupling. So the trunk is kind of decoupled from the cabin, and therefore the rear seats and things will block or filter out certain frequencies. So it doesn't always mean in a sedan, for example, maybe firing them up or towards a seat opening or something might work better. And it also depends on what type of box that you have your subs in. Port boxes are more sensitive to direction than sealed boxes. Okay, so but yeah, in the main, the best way to aim your subs is towards the back of the rear of the vehicle, as opposed to firing them towards the front, just because of boundary loading. Okay, so moving on. This sort of talks to this thing of what we call coupling. So if you're in an SUV or a hatchback where the cargo area and the cabin space is one area, then there's a high degree of coupling, right? Because they're basically one air mass. But if you're if you have your subs in an enclosed trunk, then you have low coupling because they're two separate air areas. So often if you create an opening, so open the ski hatch or drop the rear seats, the bass response will change at the listening position for you. So if you're not happy with the bass, and some of those things can help by moving the sub to a different location, maybe pointing it a different direction, create an opening if your sub is in the trunk. All of those things can change the bass response for you at the seating position. So the next thing we're going to talk about is tuning, or I could probably have changed this section to active versus passive systems or something like that, but we'll go with tuning for the moment. That's fine. So as we said before, your unique sitting position, your unique physical characteristics of your car, where your speakers are located, the distances and angles and things will all interact with the cabin, and from your unique listening position, the sound's going to bounce around and all of that stuff. But you sitting here in this particular car with these speakers, particular locations, all aimed in a particular way, you're going to experience a certain sound, just because of the physics and the geometry of the car. And it's going to sound quite different if you're sitting over here in the passenger seat. The passenger seat will have its own fingerprint of sound profile, right? And if I'm in this car, it's going to sound different again, even if I was using exactly the same speakers, because the angles are different, the aiming is different, the geometry of the car is different, and so I'm going to have a different listening experience than this guy in this car, right? And unless I have a DSP and I'm able to change the timing, change the EQ, change the levels, and tune the car for this particular location in space, then I'm going to just kind of be stuck with whatever the car gives me, right? Oh, but socket, I can buy speakers with passive crossovers, right? Yes, some speakers come with passive crossovers, but all that is the crossover. It's not doesn't allow you to change the timing, doesn't allow you to change the levels, and all that type of stuff. All it does is applies a crossover to filter out certain frequencies that the speaker is playing. You're largely still getting the speaker response. That is a sum of your listening position and the geometry of the car and your speaker distances and all that type of stuff. And so this is why car audio tuning is important, because this is why the car sounds, or a system sounds bad when it's poorly tuned, because you're getting all the reflections and cancellations and all of this stuff going on. Things are not in time, things are not leveled and EQ'd properly, because they're doing whatever they're doing, bouncing off stuff in the vehicle, right? Now, back in the old days, I'm talking 20, 30 years ago, when they didn't have DSPs, they would physically, mount speakers in path length distances and things, and do physical stuff, so they got the best sound result between the interaction of the cabin and the listening position, right? But these days we don't need to do that. We have DSPs, right? And this is why I always say two things: that if you're going to build a car audio system, a DSP with even the most basic features like time alignment, EQ, and level matching, or the ability to change levels, will allow you to shape the response of your speakers. Without it, you are really just at the mercy of whatever's happening in your car. And if you don't have your system tuned properly, then of course you're going to hear reflections and all the other stuff, right? So what a DSP allows us to do is change the crossover frequencies and the slopes, add or remove delay, so get all these speakers in time, able to EQ the speaker responses to tame dips and peaks caused by reflections and cancellations and stuff like that. So the DSP allows us to kind of shape the experience that I get at the listening position by changing all the parameters of the speakers. And for example, if this is causing a peak because it's interacting with another sound wave, then I can tame that peak with EQ, right? It creates a different listening experience for this particular point. It will sound quite different over here, but for this point it will all be in tune. So tuning doesn't eliminate reflections or these things in your cabin. What it does is it moves the problem somewhere else to a different point in the car, and but it's not any longer at that kind of listening position, right? And that is the magic of tuning. All right, the next topic I want to talk about is standing waves and cabin gain. Now, these are acoustical phenomena that occur inside your cabin, and they're driven largely by the cabin dimensions. I'll talk about standing waves first and come back to cabin gain in a moment. But these two things are interrelated, and I'll explain why. But first, standing waves. So a standing wave is a phenomenon that occurs when a sound wave bounces off a reflective surface and then interferes with itself, right? So let me show you why it's called a standing wave, just using this little diagrammy thing. So when I click play, you'll see the sound waves kind of moving to from left to right, and then they're going to hit this surface and bounce back on themselves, and you'll see what happens, right? So here I go. Let's click play, and you can see the waves that are moving this way, and then whoops, I'll try that again. You can see the wave starting to reflect itself, and then it starts to oscillate in one position, right? Just goes up and down. And this is why it's called a standing wave, because the incoming wave and the reflective wave interfere with each other in a way that makes the sound wave not move in a direction anymore, but just oscillate up and down, right? So that's why it's called a standing wave. So if we think about it in car audio, let's say that we have our subwoofers playing in the trunk of the car, and the sound wave is moving through the cabin, and it hits the windscreen and bounces back on itself. And so now we have a incoming wave and a reflected wave starting to interact with each other. And like all sound waves, they're going to sum up in some places where they have constructive summation, and in some places they're going to cancel each other out, and so that sounds like louder bass and a sort of dead spot, right? So you can, if I just use this little diagram, these points here where the incoming wave and the reflective wave are cancelling out, it's going to sound like a dead spot, and these 2 points where the incoming wave and reflective wave are adding up together, it's going to sound boomier, right? So depending on where you're sitting in the car, the standing wave will sound either like a dead spot or a boomy spot or a boosted spot or something kind of in between, right? Now, standing waves, when we're talking about this traditional standing wave boominess or flat spot, we're really talking about low frequencies, and I'll explain why low frequencies behave like this but high frequencies don't. So low frequencies, and I'm talking about frequencies below 250, 300 hertz, usually your mid-range, your mid-bass and your subwoofer frequencies, right? Now the reason that you get standing waves with low frequencies is because the wavelengths of these low frequencies are getting close to the cabin size of your car. So if your cabin size is 2.5 meters or 3 meters or something, then you're going to set up these interference patterns that act like standing waves. And because these wavelengths are so big, there's only 1 or 2 crests and peaks across the entire length of the cabin. You tend to notice these hot spots and dull spots because there's only 1 or 2 of them, right? When they, if you happen to be sitting in the right position in the car. The other reason why you tend to get standing waves with low frequencies is because low frequencies have a lot of energy, right? You think about the amount of energy that you put into a subwoofer versus a tweeter. That energy, there's a lot of energy, it's hard to absorb by the seats and the carpets and the headliner and all that type of stuff, right? And so you get this traditional standing wave kind of phenomenon or acoustics where in some points in the car the bass is very boomy where it's adding up, and some points we have dead spots, right, in the bass response. Now compare that to high frequencies, right? Things from your mid-range and your tweeters, 500 hertz and up. Their wavelengths are very, very small, many times smaller than the size of the cabin of the car, and so they're very hard to pick up because there's so many peaks and troughs. The amount of energy from those speakers is much less compared to your subs and mid bass, and so that energy is more easily absorbed by the seats and the carpet and the headliner and things. And so what high frequency standing waves or reflected waves sound like is comb filtering, image smearing, poor clarity in the sound, so it doesn't sound crisp, it sounds blurry. That's what high frequencies sound like. Low frequencies sound like hot spots and dead spots. So that's kind of standing waves. Now it gets a bit technical because standing waves are not just one frequency, they are a series of nodes, a bit like a comb filter for want of a better term. But you have mode 1, or node 1, node 2, node 3, node 4, node 5, and there's a mathematical formula to work them all out, but it's usually the first node that is the most pronounced and most notable. The other nodes tend to have less impact, right? Even though they're there. And the frequency of the first standing wave node is determined by the size of your cabin. So if you take a very small cabin like in a single cabin pickup, then the standing wave frequency might be 90 hertz, right, because it's such a short cabin. Whereas if you're in a big SUV where the cabin is much longer or you've got much more cabin space, the standing wave frequency might be 50 hertz. Now how does this kind of show up? Well, classically, when we're doing our subwoofer RTAs, often you'll find we've got a great big dip somewhere in the somewhere in the subwoofer response, somewhere between, I don't know, 50 and 100 hertz. And, often this will be a cancellation caused by a standing wave, right? Yeah, or the other thing you might find is instead of a dip, you might find a boost. In this case, here's a boost here, somewhere around about 40. And once again, it's not always the case. It could be a cancellation with something else or a boost, something else going on in the car, but often these are standing wave related issues with your subwoofer response. Yeah, so the takeaway is that standing waves will be different depending on where you're sitting in the car. Often, if you're sitting at your driver's seat position, and the standing wave is over here, it may not have any impact on you at all, right? But if you're sitting in your driver's seat position and the bass sounds thin or at a particular frequency, there seems to be a bit of a dip, then it may be a standing wave. And so what can you do about that? Well, the first thing you can do is move the sub to a different location, or change the crossover slope of the sub, from 24 to a 12 dB or something, or add a little bit of delay, or add a bit of EQ, or or at worst add a second subwoofer. Now what you're doing there is not necessarily eliminating the standing wave. All you're doing is moving the interference pattern, so it's maybe not cancelling out exactly at your listening position, but moving it forward, back, or something else, right? But these are all things that you could do if you've got a standing wave problem that's impacting you at the listening position. All right, next I want to talk about cabin gain. So we just talked about standing waves, where the wave is traveling through the cabin and bouncing back and causing interference patterns. But a cabin gain is when you get the length of the wavelength of the sound frequency, which is longer than the cabin. And what happens is the sound wave can no longer fit in the cabin. Now I'm simplifying this, but basically what happens is the sound wave starts, or the air mass starts acting like a big pressurized vessel. So as the subwoofer moves in and out, it moves the pressure sort of in and out with the cone of the sub. Now, as I said, I'm really simplifying it, but I guess you can kind of think about it like putting your finger over the end of a bike pump and pushing. You pressurize the cabin, and therefore on your ears the bass sounds louder, and so it kind of looks a little bit like this. So above a certain frequency, dominated by the length of your car, you get standing waves, which we just talked about. And below that frequency, it starts to show itself as cabin gain. And what that means is, because you're pressurizing, for want of a better term, the cabin, the lower frequencies start to sound louder and louder, right? And that's what people look for when they want to get cabin gain. They want louder sounding 30 hertz or 20 hertz frequencies, and you get that because of the as I said, the pressurization of the cabin and the air moving as kind of one mass. So there's a couple of things that affect whether you get a good boost of the low end through cabin gain, and part of that is called coupling, right? We touched on this a little bit earlier. So coupling is where the air mass is connected, right? So I might have hatchback, and I've got the sub in the cargo area, and effectively it's all one air area. So in this type of configuration, if your car is like this, you tend to get better cabin gain because you've got one air mass sort of moving together, compared to having your sub in a trunk, that's sealed off from the main cabin. You will still get cabin gain because it's more about frequency as opposed to air pressure. Like turning up volume doesn't improve cabin gain. What it does is the back seats and the whatever separate these two air masses and tend to filter out certain frequencies and things like that. And so it's much more difficult to get good cabin gain when you have your sub enclosed in the trunk. Yeah, so what can you do to improve cabin gain? One of the things you can do is improve coupling, as I said, drop the back seats, open the ski hatch on, if you've got your sub in a trunk, that will help. The other thing that reduces cabin gain is air leaks. So you think about it like a leaky balloon. If you've got air leaks from the seals around your trunk, or you've got frameless windows, things like that, seals on your windows, window seals and around your doors, air escaping through vents and things like that will reduce cabin gain as well. Where you place your sub has an effect. So as we've said before, if you can place your sub firing back toward the back of the car, you get some boundary loading that can help with cabin gain, and reducing rattles and things like that. It doesn't actually increase cabin gain. What it does is those rattles and things sort of just detract from the bass, and your bass will sound cleaner if you don't have as many rattles and things. And that's part of why there's a lot of sound deadening and bracing when you aim for those higher volume levels. So as I said before, cabin gain and standing waves are related around a particular frequency, which changes the behavior of the acoustics in your cabin, which is largely dictated by the length, but typically the whole dimensions of your vehicle. So there you go. So one of the topics we haven't spoken about is bass in convertibles. Now, when I'm talking about convertibles, I'm talking about soft tops versus hard tops, right? So typically in convertibles, it's much harder to get good low-end bass, ultra low bass, below 30 hertz. And there's a couple of reasons for that, but part of it is because of cabin gain, right? And convertibles tend to have poor cabin gain because with the roof up, you tend to get air leakage through the roof seals. The windows tend to be frameless, so you get more air leakage, through that compared to a framed window. That type of stuff. And of course, with the roof down, it's all free air. There's no opportunity for the cabin gain effect to develop, right? So you tend to find that with convertibles, the bass is pretty good from 40 to 90 hertz and up, but below 30 hertz and 30 hertz, 20 hertz and below, it's rather hard to get those ultra low bass compared to a hardtop vehicle, because in a hardtop vehicle, the that low end is helped by cabin gain, right? And it's much more difficult to attain in convertibles. So if you have a convertible, certainly one thing you can do to help your bass is to have the subs in the cabin, and of course more cone area and power will help as well. And now it's often quite difficult to achieve both of those goals, because in convertibles often the trunk of the car is where the roof is stored when it's folded down, so you can't really put big amplifiers and subwoofers in that area unless the roof is removable somehow. And of course often in convertibles, the rear part of the car, if they're roadster or something like that, there isn't often a lot of room for subs in the back, unless you sort of lose the rear seats and stuff like that. But so if you've got a convertible, my advice is don't try to chase that ultra low bass. Try to focus your bass on 40 hertz and above. You can get some pretty good results without needing to throw that extra power that you need to offset the cabin gain that you'll get in a hardtop. All right, let's have a look at some of the other things that can occur, acoustical things that can happen in your car, and these are panel resonance, ringing, and dampening. So panel resonance, well, let's put it this way: all things want to vibrate. Like a door card or a trunk lid, or whatever, and they're going to have a natural frequency at which they vibrate, and that's called the resonant frequency. So door panels, trim, trunk lids, will all vibrate when they're close to subs or close to mid-bass speakers, because they're close to the panel's resonant frequency. Ringing is how long that vibration occurs for. The more ringing that you have, the more distortion and the less clarity you'll have in your sound playback. Dampening is the opposite of ringing. It's kind of like a material's ability to absorb vibrations, right? So soft materials in your car interior, like the seats and the carpets and stuff like that, will absorb resonances. Using butyl sheets, foam, and other sound treatment materials can increase deadening and prevent ringing. Now, big cars suffer more from this than small cars because everything is bigger and wider and more surface area, right? But there's, I guess in big cars, there's also more dampening in the cabin because you've got bigger seats and more carpet, right? So what can you do about all of this stuff? And the real answer is sound treatment, right? Sound treatment, so butyl to stop resonances, foam to stop surfaces touching and squeaking against each other, and mass-loaded vinyl to block sound waves, right? Okay, so let's go through and kind of summarize all these things up. First of all, we talked about stage width. So you tend to find with bigger cars, you'll have a wider stage width than with smaller cars. Seating position, if you're close to reflective boundaries, you get boundary gain, but the flip side is you get more peaks and nulls and cancellations and things from reflections, compared to big cars where you tend to be further away from the boundaries and are less prone to those types of effects. Then we have standing waves. Small cars, you tend to have standing waves with a higher frequency, or the first node is at a higher frequency than a large car, right? And then in cabin gain, you tend to find that in smaller cars, it's easier to get low-end boost because of cabin gain, but it's much more difficult in big cars to get that cabin gain low-end boost because just the sheer difference in cabin sizes. Then small cars suffer less from resonance and ringing and stuff like that because the panels are physically smaller and there's less surface area, and the opposite is true for larger vehicles. So what can you do about all of this stuff? Stage width is, well, you can't do much about the size of your dash, but you can maximize your speaker placement to give you the best width that you possibly can with your particular car and its design. In terms of seating position, speaker aiming, sublocation, using a DSP so that you can tune the response or the cabin response to your particular listening position is the way to deal with seating position related acoustics. Standing waves, changing the sublocation, the sub's crossover slope, playing with delay, EQ, maybe installing a second sub if you're having standing wave cancellations or something at your listening position. There's some of the solutions there. Cabin gain, trying to get that ultra low boost, improving coupling between the air mass from the cabin and where your sub is located, trying to minimize air leaks, where you place your sub and trying to get some boundary loading, using sound treatment to stop rattles and things that give you much cleaner bass, are all solutions to try to improve cabin gain. And finally, panel resonance and ringing. The answer there is sound treatment. So yeah, a lot to take in. So next we're going to talk about vehicle design and features. So what we're talking about here is your unique car will have very specific characteristics, right? So you might have a one cabin pickup, or ute as we call them in Australia, and so in this case you'll have a super short cabin and not a lot of room to install amplifiers and subwoofers and things like that, because there's not a lot of free space, right? The cargo area will be largely open, and all of that type of stuff. And then maybe you've got a convertible. We already talked a little bit about convertibles earlier. Once again, space might be a problem because usually the storage area for the roof is in the trunk or the back of the car, and other issues with convertibles, or maybe it's a people mover, right? So a super big cabin, a little more difficult to get really super low end and get that sort of cabin gain and stuff like that. You probably want to put a multi-seat tune into something like this, so you probably got a lot more speakers than need, different types of DSPs and things, or maybe you've got a small compact hatch. So look, each car is very different, and so we're going to have a look at how the different features and design of cars have an impact on your car audio system. And there's not much you can do about those things other than go out and buy a completely different car, but it doesn't usually work that way. Usually you have a car and you want to put an audio system in it. Most of the time you don't sort of go out to the market to find the perfect car, to put a car audio system in it and buy that car specifically. I mean, it has been done and people do it, but it's not as common as the standard way, right? So, my wife has a car, she wants a car audio system. I'm not really going to pick, her car is her car, and I need to pick the equipment that's going to work with the car, not the other way around normally. So let's go and take a look at vehicle design and features and how it impacts on your car audio system choices. So guys, we're going to take a look at a few car interiors, and I'm going to use this little virtual car virtual tour thing. Allows you to look around the car's interior and sort of around the back of the car and all that type of stuff, because we're not really that interested in the outside of the vehicle when it comes to car audio. What we're more interested in is where we're going to put stuff and install stuff, and stuff, do we have enough space for the speakers and things that we want to install in the car, right? So we're interested in looking at things like, the pillars and the dashboards and the door cards, and, is there enough room to fit the speakers that we might want to put, or if we're going to have extra controls, is there somewhere in the dash where we might be able to put them? Unfortunately, we can't look under the seats in this little virtual tour, but checking the room, how much room you have under the seats, and in the back. Can you mount things in the C-pillars? Where might your subs go? Can you improve coupling? If you have an enclosed trunk, all of those types of questions. So I'm going to use this little virtual tool thing. Now it's from a site called Chio Space, CHIO Space, if you're interested in playing around with this tool. But we're going to start with this little vehicle. It is a Mitsubishi Outrage, Attrage, so Outrage, I think that's how you pronounce it. It's a little 4-door sedan. So just having a quick look inside. So what are we interested in? Well, as I said, where are we going to put things like tweeters, mids, subs, mid-range? Can we put them in the kicks? Can we put them in the doors? Is there room in the sail panels or the pillars? How big is the dashboard? If we want to put an extra volume controller or something like that, can we see places to fit them? If we're going to put a front sub, it's all of those types of questions. Now, I'm not going to go through each of those. We're just going to look at the car's, features and how they've been designed. So, this is a pretty standard car interior. It's got, some pretty wide A-pillars. We should be able to get some speakers up onto those if we want. Looks like we've got some space here in the sails. It's a little bit difficult to see the door cards here because it's all quite black, and same in the kicks. It's difficult to see down there, but looks like some sort of map pocket or something in here. So maybe we could build some enclosures. The gap between the door and the driver's seat, seems to be a bit of room. Hard to tell just from the pictures. But the dashboard is certainly very deep, very broad. It's got an airbag thing here, which might be a problem if you want to sort of install big speakers up on the dash. Yeah, it's a little hard to tell. And by the angle of the A pillar, and it might just be the photograph, I'm not sure, but it certainly looks to be quite a shallow windscreen angle. You might be able to see it from the outside. It's hard, yeah, doesn't look overly shallow, but that might be important if you're putting mids up on the dash and stuff like that, right? So yeah, hard to say. What about the rears? Where would we put stuff? Once again, it's hard to see under the seats to see if we could put amps or things under there, but certainly the C pillars up here, certainly big. We could put rear fills up there if we wanted to. You can see the parcel shelf here, so it's an enclosed trunk. It looks like it's got a ski hatch, so we might be able to open that to improve some coupling. But yeah, pretty standard looking, kind of car. Yeah, there you go. All right, so that's our small little four-door sedan. Let's go have a look at something a little smaller. So we're going to switch to this little fella here called a Kia Niro. So it's a little four-door hybrid hatchback. So let's have a look at him. All right, all of these interiors seem to be black, so it's difficult to see, but let's have a look. Once again, the pillars look pretty broad. It looks like it's got speakers in the corners, maybe a center channel. Also has sails, so we could always put tweeters in there if we didn't want to put them on the pillars. But yeah, it looks like stock locations could be used. The dashboard looks pretty cluttered. I can't really see anywhere where I would mount, this is all, I wouldn't put anything there, and all this is full of controls. Maybe there's a space here that we could put an extra volume knob or something if we needed to. Hard to tell. I can see a bit of a map pocket down here, so maybe an opportunity to build a box. Yeah, so once again, just like the other car, nothing crazy. Quite a lot of dash. The dash is quite broad, quite a shallow windscreen by the look of it again. But it does have this funny ridge running through the middle of it, which might mean putting in mids on the dash. That little ridge might make things a little more complicated to do. Looking at the rears, okay, so it's a hatchback. You can see there's no parcel shelf there, so looks like hard to tell, but probably behind these seats is enough cargo space to put a sub, maybe in a box, that you could remove if you wanted to. You've got some C-pillar-y things going on here. Do they have speakers in? I'm not sure, but certainly an option for if you're doing a multi-seat build or something like that. Maybe you could even put some speakers way back here in the back of the C-pillars, depending on room. But yeah, once again, nothing out of the ordinary. Pretty typical little car interior, right? Okay, so that's that one. Let's have a look at a Citroen, French car, and this is the Citroen. This is a four-door. It's almost, well, I guess it's another four-door hatchback, but it looks like the cargo space is a bit bigger, so maybe it's a six-seater. French car, as I said, Citroen Space Tourer, C4 Space Tourer. So let's have a look at this one. Okay, so straight away, what's interesting are these pillars, right? We've got a pillar here and a pillar there, so that might make mounting tweeters on the pillars. I mean, where would you put them? Maybe there, but they look pretty narrow at those points. Yeah, quite an odd design. A very, very deep dash, although quite complicated. It looks like might be some speaker grills here in the corner. Not 100% sure, but yeah, that would be quite a challenge to fit speakers in there, and they would look like they'd be pretty, if you put speakers here and here, that means the stage width would be quite narrow. If you wanted to make it wider, you'd need to put speakers over here, and then of course there's vents, so yeah, that would be quite a challenge. So down here in the door cards, big map pocket. So if you're prepared to lose that, you could certainly make a big enclosure. Looks like it's got space for mid-bass, stock space for mid-bass down in here. Once again, the console control area. You've got seat controls over here. Looks like there's plenty of storage space. You could pop a volume controller or something down in here somewhere if you had to. Maybe even up here on the door if you really wanted to. But yeah, quite an interesting design. The roof is also. Anyway, let's have a look at the back. So yeah, it looks like it is a six-seater. I can see another row of seats at the back there, which means where would we put the subwoofers and things? Probably a lot of cargo space back there. So now we're dealing with B, C, and D pillars. Depends on whether you're doing a multi-seat tune or not in this type of car. But yeah, it's the pillars and things are a little bit. It's hard to get speakers onto that. You might get them in there. Hard to see the door cards. So yeah, interesting. Just another different design with its own design challenges. All right, let's move on to something else. Let's go back and look at the Kia Sorento. Let's try that out. So this is a medium size, or I wouldn't say large, but a medium size SUV, sort of family car, hatchback SUV type thing. So let's have a look at this. Once again, quite a deep dash, but quite complicated, right? So lots of cutouts and curves and things, which it just means that mounting dash mounted mid base onto this is quite difficult. Pillars, pretty average, not wide, not too skinny. Clearly they have stock locations for what must be tweeters. Bit fancier. This might be the mids here. On the doors, I'm not 100% sure. Once again, everything's in black, so it's hard to tell. But I can see map pockets down there, so it looks like there's plenty of room for that stuff. Dashboard is also pretty crowded. Trying to find space for additional controls might be an issue. Maybe if you lose this little coin pocket or something, put something in there maybe. All right. The ceiling got some controls up here. It looks like it's got a big open sunroofy area, which usually means more leaks and stuff like that, air leaks, so cabin gain. And this is going to be a big trunks, big cabin, so once again, it's going to have difficulty getting that super low end because of the cabin lack of ability to generate cabin gain. Big D pillars in this one. So plenty of room for rears and things like that. Hard to see the rear door cards. Let's go sit in the back and see what's going on. So yeah, I mean, behind all of these things are probably a little bit of room to put stuff. Plenty of room for speakers and things. But right here in the back, right, I mean, behind these seats, once again, the challenge is going to be able to find space for things like subwoofers, right? Because there's really no cargo space. Once you fold these seats down, you're probably using the space that the folded seats, put stuff on top of these folded seats, and you've got some cargo space. But probably fold these down, you've got even more. But yeah, where do you put things like subwoofers? That would be a challenge. And once again, it's difficult to see underneath the seats to see how much room you actually have. So yeah, okay, that is the Kia Sorento, I think it's called. All right, well, let's have another look at an SUV. This time, the Mitsubishi. What is this called? Outlander, right? So quite a large SUV now. Once again, family car. So starting at the front, we've got quite big pillars. Looks like tweeters already in the pods. Huge, wide dashboard. Looks like it's sculpted, so it looks like a big scoop out, so it's certainly not dead flat and easy to mount front mids into. Hard to see the door cards again, but once again, it looks like there's map pockets. And whenever there's map pockets that you're prepared to lose, you can always fill them in with enclosures. Dash looks pretty crowded. Yeah, but nothing unusual in here. Hard to see how much room you've got in the footwell here if you want to put a front sub. It's always difficult with these black interiors to see what the hell's going on. Super wide bead pillars, not that that really helps us. Okay, so the rear is pretty much the same as the one we just saw, but these got big wide C and D pillars, plenty of room for rear speakers in there. Once again, if we have a look from the back, it's the same kind of problem, right? Once I've got the seats folded down, there's virtually no cargo space behind me. Yeah, what can you do, right? Yeah, probably space behind here for mid bass and stuff like this. If you're doing a multi-seat build or something. But yeah, once again, plenty of room for passengers, not a lot of room for car audio stuff. All right, that's the Mitsubishi Outlander. All right, so now let's look at a two-door coupe, and I don't have a lot of choice here, but I'm going to use something a little more exotic, and that's the Porsche 718 Boxster. Now I don't have an external view, but I can change the color of the interior to this light brown color, which makes it much easier to see. So this is a two-door coupe, nice car. Many of us wish that we could afford something like this, but they're just they're a car, and they have all the same type of features. But we got nice, wide, pillars. Looks like speakers in the corner. Looks like some sort of center channel thing going on here. Looks like mid bass down here. Pretty much in the kicks because there's such long doors in these coupes. So you can put them in. You put the speakers in the doors, but they're essentially in a kick location. I suppose you could put the speakers way back in here. Looks like a lot of leg room, so you could probably get a front speaker in down there if you didn't want to lose the glove box. The controls, we're going to put extra controls, maybe up in here somewhere. Is this an ashtray? Not sure. Maybe I could put something underneath the ashtray cover. But door cards, yeah, they look like they come with some pretty beefy enclosures anyway, right? There's the enclosure there. Here's the door card back here. You could fit something pretty big and deep into that area there for sure. All right, so that's all that. Now the problem will be the rears, right? So you don't really have any storage area whatsoever. Probably get some speakers into the rear door cards, or maybe up here if you're just doing rear fill. But subwoofers, locating subwoofers, probably be a challenge. So the rear of certainly this car has an engine in the back. Is it in the back or is it mid-engine? I'm not sure. But anyway, I don't think there's a lot of, there is some storage space in the back. It's usually tiny, the size of a suitcase, and they often, will have some storage space here in the front. So yeah, locating big subwoofers might be difficult, right? So yeah, okay. So we're going to look at one more car, and that's going to be an extra special car. This will be the McLaren. Let's see, a McLaren 765L. So once again, I don't have an external view, but I am able to look at this. Now this is next level, right? This is certainly not like some of the cars we've looked at earlier, but yeah. Okay, so what can we say about this? We've got some really fancy, funky pillars going on in carbon fiber Alcantara, I think is how you pronounce it. you got some speakers here in the sails. The dash is a super individually carved work of art. I think it's going to be difficult to try to put speakers anywhere but in the stock location. So you can see there's speakers here and there's speakers here, and if I switch to a different color, can I see? Not sure where, if they do have mid ranges. Maybe they do down here, I'm not sure. But yeah, that would be a bit of a challenge. Certainly very deep footwells, you could do something, putting extra volume controllers and things in. Yep, good luck with that. The console is super tiny. And of course, rear speakers and subwoofers. All right, well, that's what the rear looks like. Crazy looking pillars. And of course, all of this covers the engine, which I think if we flick back to this view, no, maybe this one here, the one we started with. And if we kind of look behind us, okay, there's a little viewing window down into the engine. So I'm pretty sure you're not. It looks like they might have some rear speaker covers here, or maybe that's some sort of vent so you can hear the engine noise or something. Who knows? If you own one of these, you will know. I certainly, I'll never own one of these, but yeah, there's probably not a lot of room behind the seats. My guess is, once again, there's a little bit of luggage space up in the front engine, where the engine would normally be in a normal rear-wheel drive car or something like that, where you probably need to put amplifiers and those types of things. Isn't a lot of room to otherwise mount amps. Certainly won't be any room underneath the seats in this car. So yeah, so I don't think many of us will be doing a DIY in a McLaren. But anyway, a bit of fun, just to show you that every car has a different feature, and every car has its own specific designs, and it will create its own specific challenges. And you need to consider the unique features of your vehicle when it comes to designing your audio system. So when we're interested in looking at cars' designs and features, we're looking at several things, and one of those is speaker locations. Where we're going to mount the speakers that we want to install. Tweeters, mid-range, mid-bass, subwoofers, maybe super tweeters. Maybe you're going to do a two-way system or a three-way system. You will have kind of decided these things based on whether you're trying to do a budget build or an SQ build, or maybe you're going to do an OEM build and you're not so worried about where the speakers are going to be located because you're going to use the car's OEM locations. But for most of us who are going to try to choose where we're going to mount things, your car design and features are going to play a big role in deciding where you can and can't put things. So one of those is how big are the pillars, how much room do you have in the door cards, how much room have you got underneath the seats, can you fit speakers under the seats, is there enough clearance in the door cards, is there enough depth so that you can mount a speaker without the speaker hitting the window mechanism or interfering with stuff in the door itself. Now one of the things that people might do is actually build up a speaker ring. You just got to be careful that you don't create almost like a tube effect and color the sound, because the sound is the back wave or the front wave is making its way through a big tube. So it's one of the things to consider when you're thinking about mounting your speakers in the door cards in what I would term free air. That means mounting it on a ring and having the speaker vent into the void inside the door card itself, right? And then of course there are kicks. Can you fit speakers in the kicks either in a box or into an IB configuration? Is that going to interfere with you operating the pedals in the car, or do you have the room? Is there fuse boxes or other wiring components or electronic modules and things that are in the way. Maybe the bonnet release or something. All of these things, your specific car. And so in one of my cars, the bonnet release is actually up here near the steering column. It's way out of the way. In the little in the BMW, it's down here. And and of course I had to pick a location for the kicks without losing the mounting point for the speaker, for the bonnet release, right, which was kind of here. So I couldn't make a custom plate, to enclose the speaker, because then I'd have to find a complete new way to mount the bonnet release cable, right? And so I had to retain the original kick plate out of the car, so the bonnet release would still work. So they're the types of things that you got to think about when you're looking at your car's design and features, when you're deciding where to put your speakers. And technically, a subwoofer is a type of speaker, but I'm going to talk about them separately because they take up a lot of room, of course. And there's lots of options which we talked about earlier. In boxes, in the trunk, built into the wall of the trunk, into footwells in the front of the car, or under the seats in the car, all different areas. But it's often quite difficult to, these take up a lot of room if you don't have a lot of cargo space, or you want to keep a lot of cargo space. Some of those examples that we just looked at in those big SUVs, maybe an underseat sub solution like this that we have here, box that's built underneath the rear seats, maybe a solution for those ones where there isn't really a lot of options for subwoofer installations. The other thing that we're sort of thinking about, so we've got speakers, subwoofers. The other thing is, where do we put all the amplifiers and the DSPs and all the electronics and fuses and things? And once again, there's lots of different spaces to put them. People would put them in the trunk, either sort of under the trunk cover, or on the sides, or wherever. But there is options to put your amplifiers under the rear seats, behind seats. Like for example, if you've got a pickup, it's not unusual for people to mount amps and DSPs on the back of the seats, or on the back of the rear wall behind the front row of seats, or something like that. Or if you've got room underneath the seats themselves, is another option. So once again, when you're looking at your car's particular design and features, you've got to think about where you can whereabouts you're going to put your DSPs and amps, right? And keep in mind that you're going to want to make sure that they don't overheat, so ventilation, being able to access them easily, because something will come unplugged one day, or you might need to reset the gains for some reason, or so not having to take the car apart just to get to your amplifier or DSP is always a great thing. All right, the other thing that your car's design will dictate will be the speaker choice, right? How big a speaker you can fit, how deep or skinny the speaker needs to be. So a classic example is a mid-bass in the door, mounted on a ring in free air, right? Usually there's a pre-cut out hole, and there's nothing to stop you cutting something a little bit bigger, but this looks like an 8-inch, could be an 8-inch speaker. Let's pretend it's a 6.5. You might be able to squeeze an 8-inch in, but it's probably where you close the door and you can kind of see, that's probably, if you go bigger, you're probably going to interfere with the ability to close the door on the edge here in the seal, right? So you're going to have a maximum size that you can fit in this hole. I mean, you're not going to be able to put a 12-inch speaker in there unless you build a massive custom sub, right? And it's the same with things like sail panels or pillars. There's only going to be a certain size of speaker that you can use without interfering with your ability to see past the A-pillar, or maybe the depth of the A-pillar. You may need to build it out, or or do something because there's not enough space behind the A pillar for your tweeter to be fitted or a mid to be fitted. So I guess the takeaway is, when you're looking at your car's features, it is going to dictate somewhat the size and shape of the speakers that you can fit. And of course, equipment choice, right? Oops, sorry, let me go back. Equipment choice is also influences by a car's design and features. So a classic example, if you're going to put stuff under the seats, they're going to have to be a certain, height and depth. Otherwise they're simply not going to fit into the location that you've got available. And this goes for all types of things. Your amplifiers, your DSPs, your size of the sub boxes that you can choose, but we're talking about equipment here, so you need to choose equipment based on the what available space that the car design and features present you. So there's always a good saying, right? Don't fight against the car, work with what you've got. So once you've said, hey, the best place to mount my DSPs and amps is going to be under the front seats because I just don't have the space in the boot, or I want to keep it pretty stealthy, so I don't want amps everywhere, and I don't want the kids throwing sports gear in there and damaging them, so that's where I'm going to put them. Oh, fantastic. Okay, so once you've identified that location, well then you're not going to be able to go out and buy 3 foot long AB class amplifiers, right? They're simply not going to be able to fit, so you're going to be restricted to D class small form factor amplifiers, and maybe instead of having an amplifier for every speaker, you're going to have 8-channel amplifier, right? Who's going to run a bunch of different speakers. So I guess the point is that your unique car and its features are going to dictate what you can and can't install. And that then brings us to choice of installation, right? Once again, this is a space issue, right? So if you look at this car, what can I do? I want to install some mids and tweeters, and I can pop them up here on the pillars, right? That might be fine, but if I want to put them on the dash, and what I find is there's this big cutout here, right, and a big ridge here, and it's all part of the one dash, and there's a vent that runs across the front here that aids in demisting. It's I can't really countersink a speaker there, so my choice is, if I want to put mid ranges up on the dash, I might have to use speaker pods, right, instead of flush fitting them onto the dashboard. It's probably not a great example, but I guess what I'm trying to say is once again, your features of your car may dictate your choice of installation. Another example might be your door cards, right? So your door cards might be super shallow, they might be really close to your driver's seats, and that might prevent you from actually building an enclosed box, and it might force you to have to mount speakers on your door cards using a speaker mounting ring and just having them in free air, right? Or or the kicks. You may not have the space to put things in the kicks, right? You might have to put them in IB instead of building boxes down in the kicks because you simply don't have the space. So just like equipment choice, your car will dictate somewhat the installation choices that you have as well. So in summary, when I think about vehicle design and features, and as I said, all cars are unique. They all have different features, as you saw from that little grab bag of different cars that we looked at a little earlier. They all have different design features. They all have different layouts. They all have different amount of space available. But we're really only interested in 6 things, and 3 of them are to do with location. Where are we going to put the speakers? Where are we going to put the subs? Where are we going to put the DSP and amps? Where are we physically going to be able to put these speakers? And then once we've kind of worked that out, we are then going to sort of be dictated by the car in terms of, well, the size and the depth of the speakers that we can use. the size and shape and depth of the equipment that we can use, for DSPs and amplifiers and other things, and then of course the method of install, ported box, a sealed box, installing things on a speaker ring in free air, or doing infinite baffle installs. Once again, your car will dictate pretty much what you can, or limit the choices of what you can do. But when you're looking at your vehicle and design features, it's these 6 things that you're trying to consider. All right, so now we have spoken about size and shape, design. I now want to talk about value, ownership, and future plans. Now, this is something that we talked about a little bit earlier, but we're just going to dive in and cover this again because it is part of the car's influence on your car audio system design. Okay, so we're going to talk about value, ownership, and future plans. And as I said, we've touched on these before. But the first one is value. And value is all about how expensive your car is versus how inexpensive or cheap. And generally age is related to value, although you can get super expensive old cars, collector cars. But generally, if my car's old and not worth very much, I'm more likely to go out and just modify it and not care about cutting it up and putting holes in the floors and, drilling stuff so I can put wiring through and things like that. But if my car's new and expensive, then I'm less likely to probably do that. I'm more likely to want to keep it pretty OEM, or, if I'm going to do upgrades, then there might be, less extreme, right? That's not to say that people don't modify expensive cars. Of course they do. My friend who has a car audio shop down the road, was working on a Porsche the other day, and the guy bought the Porsche and he wanted a fully blown car audio system in it, right? So yeah, it does happen. But as a general rule, when your car is old and less valuable, you're more likely just to have some fun and do some crazy mods. And if your car is new and expensive, then you're more likely to do work that is more OEM, stealthy, reversible, that type of stuff. Which brings us to the next topic, which is ownership. Once again, just a rule of thumb, but if you own the car, you're more likely to kind of do whatever you want with it, and you're more likely to do modifications and things that you want to do. If it's a vehicle that you're leasing, maybe your lease doesn't allow you to do mods, and therefore you might be restricted to putting in a sub just in a box that you can easily unplug, right? Or maybe you're planning to buy the vehicle at the end of the lease, and you can do some things before the lease runs out. I'm not 100% sure, it depends on your personal circumstances, but certainly the fact that you don't own the vehicle will change the way that you kind of approach your car audio project, if you can do it at all. And also, if the car belongs to your wife, for example, that's a very special case. Maybe she doesn't care, go crazy, build whatever you like, but more often than not, your wife may or may not be an audiophile, car audio nut. Good luck if she is. But most of the time our wives are not, and they don't want the truck full of amplifiers. They want to be able to put shopping and stuff in the back of the car. So if the wife, if it's your wife's car and she wants a great car audio system, the fact that she owns the car is going to influence the design of the system and how you go about it, right? And then of course there is whether you plan to keep the car or whether you plan to sell it. Now once again, if your car is old and not worth very much, you're probably not going to get much for it. Like my BMW, then I'm going to decide no point selling it. I'm not going to get much for it, so I'm going to keep it, and I'm just going to use it as my hobby car, right? That might be one approach. And that's the car that I do my car audio stuff in, and I keep changing it all the time, and whatever. Versus somebody who's putting a car audio system in to enjoy it, but ultimately they're going to end up selling the car in a year or two particularly if it's a new car. So often that will drive to you to do more subtle, more OEM type of installs, or make sure that the system is reversible. So you're not cutting big holes and things. You can easily remove equipment and patch things up. So you can return the car back to its original OEM state. There's just a word on putting aftermarket audio systems into cars. They're a little bit like modifying cars. They don't really add a lot of value to the resale value of a car. So if you spend, I don't know, $10,000 on an audio system, don't expect that your car is suddenly going to be worth $10,000 more to a buyer. It doesn't really kind of work that way. So that is value, ownership, and future plans. Okay, next we come to the last item on our list, which is drive type. And when I'm talking about drive type, I'm talking about whether your vehicle is an internal combustion engine, the traditional car, or whether you have, an electric vehicle, or whether you have a hybrid, which is a cross between the petrol and the electric car, right? Because each of these vehicle or vehicle drive types clearly have a different way of driving the vehicle, a motor or an electric motor, and they clearly have different electrical systems, right? But what might surprise you is they also have different levels of cabin noise. And so the two things that will impact your car audio decisions in terms of these drive types is how to deal with the electrical systems and how to deal with the different kind of background noise that you have in your car. So we're going to take a look at these two topics today. And so the first one is the electrical systems. So if you think about the traditional internal combustion engine, petrol car, or I think in the US you guys call it gas or diesel vehicles, at very traditional electrical system, we have a battery and an alternator, and produces 12 volts, and not that complicated, right? And usually the battery is either in the trunk or in the engine bay. It's usually 80 to 120 amp hours or something like that. It's not huge. And typically the electronic magnetic interference, or the electrical noise that you get from the electrical system, is pretty rare. I mean, sometimes you get alternator whine, zzz, when you're pressing on the accelerator, and the alternator winds up, and you get this whine sound coming through the speakers. That's the most common EMI type of noise that you get in traditional cars, right? But if you look at the other end of the spectrum, at the electrical EVs, they're using high voltage batteries with a DC to DC inverter that converts that high voltage into a 12 volt power supply that you can use to drive your headlights and air conditioning and all the other stuff in the car, right? The battery is generally under the floor, tends to take up pretty much all of the floor area under the seats. So the batteries are much larger than in our traditional cars. And one of the problems, particularly with EVs, is what we call switching noise. So that is electrical interference with the audio system from the DC to DC inverter operation, right? Or other electronics associated with the electronic system in an EV, because the electronic system is obviously much more complicated than a traditional internal combustion engine car, right? EMI noise can be a particular problem with EVs, right? And of course, you've then got your hybrids, which is a cross of both. They have both petrol and electric engines. So with hybrids, once again, they've got the same as an electric vehicle. They've got batteries, high voltage batteries, and they have DC to DC inverters, which convert it to 12 volts. Those batteries are usually stored in the cargo area. So while they've got more batteries than a traditional car, they've got less batteries than an electric vehicle, but they tend to take up a lot of space, and they tend to be in the cargo area of the car, which means that putting subwoofers and things is a little more difficult because the back of the car is usually full of batteries, right? Now, in terms of EMI, the noise can change depending on which mode you are operating your car in. So, I don't get noise, when I'm running it in petrol mode, but as soon as it switches to electric, I may get some switching noise from the DC to DC inverter that's operating in the hybrid, right? So, you just need to be aware of these problems and factor this stuff into your car audio design, particularly if you're, using, for example, a hybrid or EV. Okay, the next thing is to do with road noise, right, and noise in the cabin. So, when you think about engine noise, or with a traditional car, most of the noise comes from the engine, from the road noise, like that type of thing. Whereas an electrical vehicle, when it's driving, actually the engine noise is pretty quiet, right? Like it's super quiet, right? You can't really hear the electric engine, right? But what you tend to find though with electric vehicles is they're actually usually built quite lightweight for a couple of reasons. One is they try to keep the construction light because they want to get the maximum range out of the battery, compared to a petrol or diesel car, right, which we don't really care. That's going to affect fuel economy, but we're not usually worried about range so much. So we tend to find that the build quality of traditional cars are generally heavier, with more heavyweight or rigid construction compared to EVs, right? So what you tend to find is sound treatment actually is more important in electric vehicles than it is in petrol cars. So while you think it's super quiet because it's an electric vehicle, actually you tend to find that it's you get a lot more road noise, tire noise, wind noise inside the cabin. And so that means that you really need to fully treat the cabin of the car, the wheeled arches and things like that, to try to block out or reduce a lot of that noise, which unfortunately adds weight to the vehicle, which effectively reduces the vehicle's range depending on, I guess, the model of electric vehicle that you've purchased, right? But don't think that buying an electric vehicle automatically means that the car is better for SQ because it's quiet, because that's not necessarily always the case, because of the lightweight build and often the lack of sound treatment that they do in EVs compared to traditional vehicles. Now, in a traditional vehicle, yes, the engine is typically louder, but we tend to find that the trim in the cabin and things like that generally are a higher standard, and have usually some sort of foam or other padding. Once again, electric vehicles, that's not necessarily the case. You tend to hear, because there's no engine noise, you tend to hear rattles and things a lot more than you do in a traditional car, right? So it's even more important to sound treat properly the trim and the door cards and things, inside electric vehicles, right? So all in all, with a traditional car, you can pretty much do some sound treatment and just do the doors and door panels and some trim if it's particularly squeaky or something like that. But you can get away with a pretty small amount of sound treatment. But with an electric vehicle, you probably, because there's no engine noise, you tend to hear the road tire noise, the wind noise, and all the squeaks and rattles in the cabin a lot more than you do in a traditional car. And so it's actually louder, which sounds almost counterintuitive. So you really, sound treatment really is good return on investment in an electric vehicle. Now, hybrids are a special case because they actually have bit of both worlds, right? And the noise inside the cabin changes depending on what mode they're in. So when they're in petrol mode, the engine noise is loud. When they're in electric mode, the engine noise is quiet, right? But once again, they tend to be lighter weight because they're trying to get more range from their electric batteries, but they're not to the same degree as electric cars, because I think the purpose of hybrids is not necessarily to be an electric car. It's more about fuel economy, right? So I can get more distance on my tank of gas. Once again, because when it's an electric mode, the wind, road, internal rattles and things become far more detectable than when you're running your petrol engine. It's another reason why you really want to fully sound treat a hybrid car. When I mean fully sound treat, I'm talking about the wheel arches, the doors, the trunk, that type of thing. You've got to be careful about sound treating around where the battery storage areas are. So if you've got an electric vehicle, it's not recommended to sound treat the floor, because you've got heat dissipation issues and things like that. And adding sound treatment also will effectively add a layer of thermal barrier there, right? And you don't want to do that. You don't want to interfere with the car's ventilation of the battery system at all. So be careful of that. All right, so that's really sound. So the other thing we want to talk about with EVs and hybrids, which are different to traditional, is installation, right? And that's once again because the car's laid out differently, so here's the batteries and the wiring and everything to do with an electric vehicle, for example. So one of the things that when you're doing installs, you need to be careful, because there's high voltage components. It means be careful about where you're drilling and cutting. And I just talked about be careful, what you're doing when it comes to sound treatment, because you don't want to add sound deadening or butyl sheets and things like that, and then cause a heat build-up problem somewhere in your car. Often with hybrids and EVs, they have lots of vents and cooling ducts and things, particularly for the batteries and the electronic components. So you've got to be careful that you're not cutting those vents and things if you're installing speakers, for whatever reason. So if you, for example, probably a bad example, but if you're doing a dash mid-range install, often you will cut into the ducts that supply airs to the side vents, right? And you might be happy with that. You might be happy to have less airflow through the side vents for having mid-ranges on the front dashboards. But you don't want to make those type of compromises when it comes to your EVs and hybrids, because the vents and cooling ducts are important for the operation of the vehicle. So yeah, I think you know what I kind of mean. The other thing you need to be careful of is with where are the batteries. So for example, in an EV, if the batteries are in the floors, then clearly you're not going to be able to put in IB installs. You're not going to be able to cut holes in the floor and put your mid base in the floor under the seats with the backway venting out to atmosphere, because there's batteries and wiring and stuff in the way, right? So yeah, and also of course hybrids tend to have, as I said before, the battery in the cargo area, which means that there's much less room for amplifiers and subwoofers, so you often need to find a different location for that equipment. And of course, when you think about a traditional car versus a modern EV or a modern hybrid, hybrids and EVs are far more complicated and I guess more tech integrated than traditional vehicles. And what I mean by that is they'll have sensors and monitoring systems and all this type of stuff. I often talk about the Teslas being a laptop on wheels, right? So if you're trying to integrate if you're trying to put in an aftermarket system, then there's often more difficulty in integrating that system to work with the car's normal electronics and controls, right? So, they're all the things that you just need to keep in mind when it comes to EVs and hybrids and installation, right? So, guys, now we've kind of looked at all the things that your car can influence when it comes to car audio design. I mean, we talked about the size and the shape and how that will influence acoustics and how sound behaves in your car's cabin, and some of the things that you can do to counteract that if you're having things like standing wave nulls and boundary gain and stuff like that. That's causing an acoustical problem. And we've also talked about how your car's design and features will influence where you can put speakers, how big those speakers can be, where you can locate amplifiers and things that will influence the type of installation method you can and can't use. And there's not much you can do about that. You kind of have to work with the car rather than against it. We also talked about the topic of value, ownership, and future plans, and how those things might impact, just how crazy you might go with your modifications, or whether you want to make your system reversible or not. And of course, we just talked about the drive type and how EV and traditional cars differ, and some of the things you need to think about there. So your car does really play a major role in how you're going to design and I guess install your car audio system. So regardless of what type of car you have, I hope that today's tutorial has given you some things to think about when it comes to planning your own audio system. So there you go, guys. That brings us to the end of today's tutorial. I hope you found that interesting. I hope it gave you a few things to think about, particularly if you're starting to design your own car audio system. Once again, thank you so much for tuning in and watching. And as always, if you've got any questions, feel free to throw them below. I will try to get to them as soon as possible. Otherwise, I will catch you in the next episode.